Okay, so at this point, we have mastered our other three factoring styles, hopefully. So, looking back, we've had greatest common factor. This factoring is always the one I look for. I always scan for it. I say, quickly look over, can I take something out of everything? I always look for it no matter what. Difference of squares, recognizable because it will only have two terms instead of being called a, what's the word when there's three terms? Trinomial. So a difference of squares only ever has the two terms. It also has to have a what between?
Minus.
Subtraction, because it's a difference of squares. And why isn't there a term in the middle of that trinomial?
Because they already cancel out.
Which two things cancel?
The plus and the minus.
It would be
O and I.
the O and the I components of the FOIL, right? And we've done simple trinomials. Simple trinomials always have the three parts. They always start with specifically a what?
X squared.
A 1, whatever squared. It might be a different letter, but it always has a 1 something squared. Okay. I'm just going to quickly give you, you don't need to write this down, just watch. I'm going to give you an example again of a simple trinomial. Okay, simple trinomial. So first of all, you always scan. Is there anything that you can divide out of this, and this? No. No, there's nothing. So simple trinomial. So what you're really doing when you do this is you're understanding how your FOIL makes. This times this has to do what? It has to multiply to that. So x and x. This and this have to do what?
They have to
Multiply to the L part of the FOIL.
add or subtract.
This and this are the O and the I, and they have to O and I combine to that. Okay. So what are the two numbers that multiply to this?
7 and 2.
7 times 2, -7 and +2. Okay, so this works because when you times this number, you're timesing it by a 1x. When you times this number, you're timesing it by a 1x as well. So that's why those numbers work out that way. Okay, we're doing kind of the same thing with the complex trinomial, but it's going to be different because these combos are going to get all thrown off because this isn't going to be a 1x anymore when we go to this complex. Okay, so complex trinomials. To recognize a complex trinomial, you're going to have your three components because it's a trinomial, but it's a complex because it's going to have something x squared. Okay, ready? It's going to get complex because it's called complex. Step 1, get your FLA number. So what my FLA number is what is the first times the last make as a digit? 12. And I'm going to write +12 specifically. Let's list all the sets of numbers that can multiply to 12. We're going to start with the 1. 1 times 12. Is it divisible by 2? 2 times 6. I'm going to keep going. Is it divisible by 3? Yes. 3 times 4. And that would be the end because my numbers are met up. Now, what I'm going to do with my flip pairs is I'm going to look for a combo that would add to 7. Is there any set of those that would add to 7? 3 and 4. Okay, what do you think about the plus minus stuff going on with this question? They have to multiply to plus 12, and the two numbers also have to add to plus 7. So what are you going to conclude? Both positive. Okay, now, here's what I'm going to do. We are going to make the list of how could we have possibly got the F and how could we get the L. So what could have been in my brackets to develop 6x squared? Give me some options. 1x squared, or sorry, 1x times 6x. That's an option. Those two would multiply. And then you said 2x times 3x. Those are the only options I could have put together in a bracket, right? Okay, let's look at the L. How could I possibly multiply to the L?
1 and 2.
1 times 2, and that's it. Okay, now we have to puzzle together our FOIL. I need something to partner with something that I can make a 3 and a 4. Okay, I have to put something with this and something with this together, and they're going to FOIL. So they're going to multiply something, and something else is going to multiply. And then together, I put them together, and they make a 3 and a 4. So I'm going to circle it up for you, and then you're going to see why. So I'm going to put this with this and this with this. Does that make a puzzle of a 3 and a 4 together?
Yes.
Do you see it? If I put the 3x with the 1 in that group, that would partner to be 3x. The 2x with a 2, those get partnered together to be 4x. Do you notice how I put circles and boxes around them to make sure I know what's going with what? Okay, I'm going to do 2 brackets. So we remember how FOIL works. The first times the first needs to make 6x squared. So we picked 2x times 3x. That's the first times the first part of our FOIL. Guess what I could do? Check. That's already done. 6x squared is already in this. Then we did something on the outside, and we have grouped 2x with what? What did we do as a partnership? 2x we put with a 2, and we're going to put a plus because that will make plus 4x. And we are going to put the 3x on the I. What did we do up here? We marked it. We put the 3x with a 1. And we also told ourselves that it would be plus. And we just factored it. Okay. Guess what you can do? Your brain will work better multiplying this out. If you FOIL it out, can you check your answer? Does it get back to the original? Because remember, they're the opposite process. Factoring and FOILing are opposite of each other. So ready? What's first times first? 6x squared. What do the O, then also the I, get together and make? 4x plus 3x makes 7x. Check. What does the L times the L make? 2. Look at that. You're correct. As long as yours foils back to the original, you know that you have the answer. Okay, number 2. So we're going to start with the flood digit. So we have a 2 here and a 45, so it's going to be a plus 90. Okay, 1 times 90. 2 times 45. Is it divisible by 3?
30.
3 and 30. Is that divisible by 4? No. Is it divisible by 5? Yes, it should be. It ends with a 0. Anybody do that one? 18. Is it divisible by 6? Yes. 6 times 15. What do you think? 7? No. 8? No. 9? 9 it is. 9 times 10. Done. Okay. Look through all those sets. What's the goal that you need your set to do? The set that you pick has to do what? Add to 19. Is there anything there that does that? 9 and 10 would go to 19. What's the conclusion? They have to multiply to plus 90 and add to plus 19. Both plus then? To multiply to plus and add to plus? Okay, I need, what are my options to make a 2m squared? What times what would do that? 1m times 2m. Okay, there's a few here. What are my options for 45? So 1 times 45, not divisible by 2. It should be divisible by 3. Anybody know? 3 times 15. It's also divisible by 5 times 9. Okay, so now this is the best part. This is the puzzle of it. You have to find a group of each one, and you're going to put 2 pieces together that have to make a 9 and a 10. Do you see any partners that will go together to make a 9 and a 10? 5 and 2? 5 and 2 and 1 and 9. That set with that set, I have some puzzle pieces that will fit. Do you understand you can't pick something from this set and this set, right? You have to stick to a set. Do you see the 10 and 9 pairs? So now I'm going to do 2 brackets. I'm going to put my first times my first in there. So 1m times 2m is the first partners that I picked. Now I'm going to draw these rainbows, the outside partners and the inside partners. And then you put that up there. You said I'm going to put what together? So we put 1m with a 9, and that was going to be a plus 9. And we put a 2m with a 5, and we said that should make a plus 10. Do you see, can you visualize all of your FOIL components there? First, 2m squared. Outsides are 9m, insides are 10m. That's where the 19 comes from. This last times that last is 45. Okay, I want to go to number 4 here because I need to challenge you with a different sign, I think. Okay. Fla. What digit do you get with the first times the last? Negative 60. So the negative now. So what do we already know about this situation? There's going to be something with a plus and something with a minus, right? Okay, 1 times 60. 2 times 30. 3 times 20. It is by 4. Anybody know that one? 15. It is divisible by 5. 12 times 5, and there's one more set. 6 times 10. Okay, you are looking for a set that gives you 17. Uh-oh. I can kind of see 2. 3 and 20, I could get a 17 out of that, and 5 and 12, I could get a 17 out of that. One of them is correct, and one of them is incorrect. And the reason is because I know one of them has to be positive, and one has to be negative. So can you think about it for a second? How are you going to make a plus 17? And you have one positive number out of that and one negative number. So I want you to think. No one answer it right away here. 1's plus minus. You got to get a plus 17. Did you pick this set? So this one doesn't work because of this. To get a plus 17, they would both have to be plus, and now that's not going to be a negative 60 anymore. Okay? So no, almost, but no. There's our magic numbers, a 3 and a 20. Can you give me a list of the first? So I could do 1b with a 6b. I could have also done a 2b with a 3b, right? Those are the lists of that. And then 10. The L. What are my options there? 1, 10, 2, and 5. Okay, so this is where you have to use your mental math stuff. Problem solving skills. Where's my set that has a 3 and a 20? If I combine them both, a 3 and a 20. I'll give you a second for that. You need some kind of partner to make a 3 and a 20. Did you find a set that will do that to you? Okay, I found one. I got a 3 and a 20 out of those sets. Did we pick the same ones? Okay, so now it's all about this. Putting them together in the proper spots. So I always start with the FF, FOIL. So 2b times 3b is what we picked as the first times the first. And then I'm going to draw an outside rainbow and an inside rainbow. And then we said on the outside, we're going to put a 2B with a 10. So that's going to make 20B. And what kind of 20B do I want there? I want it to be a plus 20B. Now, I'm going to connect the other two with the other rainbow. So inside, I'm going to go 3B with a 1. So that causes this to be a 3B. And I want it to be a negative 3B. And you can multiply that out. FOIL it. Does it always go back to your original? Check on your test. If I multiply that through, it should cause me to get back there.